reference instruction and input output instructions, right? So today we'll start with the timing and control, right? Now the timing for all registers in the basic computer is controlled by a master clock generator, right? And the clock pulses are applied to all the flip flops and register in the system, including the flip flops in the control system, right? And the clock pulses do not change the state of register unless the register is enabled by the control signal, right? Now this is the uh, what we can say block diagram of control unit of basic computer, right? In that this block diagram of control unit of basic computer consists of one control logic gates, one 4-bit sequence counter, right? Two decoder, right? One is of 3 cross 8 and one is of 4 cross 16, right? And number of control logic gates, right? An instruction read from memory is placed in instruction register, right? Instruction read from the memory will be placed in this instruction register, right? Where 0 to 11 bits are for the store the address of the instruction. 12, 13 and 14 are used to store the uh, operation code, and 15 is set for the uh, decide to uh, whether the instruction is indirect instruction, direct instruction, right? Bit 15 is used to decide the type of the instruction, right? Now the instruction, the operation codes, right, from bit 12 to 14, right? 12, 13 and 14 એના પર જે તમારા ઓપરેશન કોડ store થયા હશે, right? That operation code will be decoded with the use of 3 cross 8 decoder, right? The 8 outputs of the decoder 0 to 7 will be denoted by the D0, D1, D2, D3, D4, D5, D6 and D7, right? The subscripted decimal number is equivalent to the binary number of the corresponding operation, right? Now next is bit 15 in the instruction register, right, are transferred to the flip flop. Bit 15 of the instruction register are transferred to the flip flop, right, designated by the symbol I, right? Here I is a flip flop, right? Bit 0 to 11 are applied to the control logic gates. Bit 0 to 11 are applied to the control logic gates. The 4-bit sequence counter can count in binary from 0 to 15. The outputs of the counter are decoded. The outputs of the counter are decoded into 16 timing signals T0 to T15. Right? Here 4-bit sequence counter can count the binary from 0 to 15. The output of the sequence counter will be decoded into 16 timing signals T0 to T15. Right? And આનો જે internal logics છે that we will see in detail in later on topics. Right? So these are the part of the control unit of the basic computer. Right? Instruction register is used to store the instruction which is read from the memory. Right? Now bit number 12, 13 and 14 are decoded with the use of 3 cross 8 decoder and 8 output will be denoted as a D0 to D7, right? And here D0 to D7, 0 to 7 subscript decimal number is equivalent to the binary value of the corresponding opcode, right? Now, next is I 15 bit, right, will be transferred to the flip flop I, right? Now, next is the outputs of the sequence, okay, sequence 4-bit sequence counter. The 4-bit sequence counter can count the binary number from 0 to 15, and output of the sequence counter will be decoded into 0 to 15, that is T0 to T15 timing signals, right? So this is the so भाई block diagram of control unit of basic computer, right? Now the sequence counter SC can be incremented or clear synchronously. Most of the time the counter is incremented to provide the timing signal out of 4 cross 16 decoder, right? When this counter is clear to 0, right, then the next active timing signal to T0 is there, right? Now let us take one. Okay, now let's see the block diagram with the use of some binary numbers, right? Consider this is the binary instruction which is stored into instruction register, right, which is derived from the memory, right? Then 001 will transfer to the 3 cross 8 decoder, right? So this will become D1, where 1 is a equivalent binary decimal number with this binary number, so 001, so equivalent decimal number is 1, right? So it will transfer to the D1 signal, right? Now here 15 bit is set to 0, so flip flop ma કયું bit pass થશે 0, right? Now as I said, components of control unit are two decoders, a sequence counter, and a control logic gates, right? Instruction read from the memory is played into IR. Then IR is divided
USB
into three
removed.
parts, right? One is 15-bit I, operation code 12 to 14-bit, and 0 to 11. 12 to 14 bits are decoded using the decoder. 15 bits are transferred to the flip flop designated by I, right? And the 8 output of the decoder are designated by D0 to D7. Bit 0 to 11 are applied to the control logic gates, and 4-bit sequence counter can count the binary from 0 to 15. The output of the counter are decoded in 16 timing signals T0 to 15, and these S can be incremented or cleared synchronously. Most of the time, the counter is incremented to provide the sequence timing signals to the decoder. Right? And when counter is clear to 0, it will causing the next timing signal to T0. Right? Now let's see the one example. Consider the example where sequence counter is incremented to provide timing signal T0, T1, T2, T3, and T4 in sequence. At the time T4, sequence counter SC is clear to 0 if decoder out D3 is active. Right? હવે આપણે એને symbolically represent કરવું હોય, then we can represent this statement like this: D3 T4, right? At the time T4, sequence counter is 0. At the time T4, sequence counter is set to 0 if the decoder output D3 is active. Right? So this is the symbolic representation of this above statement. Now let's see the timing diagram, right? To understand the relationship of the control signals, right? So this will explain this statement. Okay, so clear input of S6 active, first positive transition of the clock clears, as it to 0, then turn activates the time T0 out of the decoder. Right. Now let's see the timing diagram for understanding the time relationship of the control signals. Right. The sequence counter SC responds to the positive transition of the clock. Initially, CLR input of the sequence counter is active. It means clear the sequence counter. Right. Now, first positive transition of the clock clears the sequence counter to 0. So initially, first transition of the clock diagram set the SC is equals to 0, right, which activates the timing control T0. So at time T0 તમારું શું થશે? Sequence counter is 0, right? So ડિકોડરમાંથી જે તમારું 4x16 નું જે ડિકોડર હતું એમાંથી કયો ટાઈમિંગ સિગ્નલ એક્ટિવેટ થશે? T0, right? So T0 is active during the 1 clock cycle, right? Now, positive transition, clock transition labeled T0 in this diagram will trigger only those registers whose control inputs are connected to timing signals T0. Right? So at the time T0 કયા કયા રજિસ્ટર તમારા એક્ટિવેટ થશે or ટ્રિગર થશે કે જેના જેના ઇનપુટ તમારા ટાઈમિંગ સિગ્નલ T0 સાથે અટેચ હશે. Right? Now sequence counter is incremented with every positive clock transition, right? Unless CLR input is active, right? Sequence counter every positive clock transition per increment થશે unless its એનું જે CLR input છે એ active, unless its CLR input is active, right? This produce the sequence of timing signal T1, T2, T3, T4 and so on. Right? Now, if sequence counter is not clear, right, the timing signal will continue to T5, T6 up to T15 because we have total 16 timing signals, right? અને ક્યાં સુધી continue રહેશે? જ્યાં સુધી sequence counter clear નહીં થાય ત્યાં સુધી. Right? Now, after reaching to T15, it will again back to the T0, right? And the procedure continues until your SC is not cleared, right? Now, here we consider, right, that at last 3 after T4, right, suppose our SC is cleared when D3 and T4 is equals to 1, right? Where D3 is the output from operation decoder, right? And T4 is a timing signal at 4th clock pulse, right? SC ક્યારે ક્લિયર થશે? whenever D3 and T4 is equals to 1, right? જે આપણે પેલું equations જોયું ને, this one. SC ક્યારે આપણું ક્લિયર થાય છે? જ્યારે D3 and T4 is equals to 1, right? So whenever D3 and T4 is equals to 1, our SC is clear, right? And D3 is a output from the decoder will become the active at the end of the timing signal T2. Right? D3 અહીંયાથી active થવાનું start થઈ જાય છે. When timing signal T4 becomes active, the output of the AND gate that implement the control function D3 T4 becomes active, right? And this signal is applied to the CLR input of the SC. On the next positive clock transition, the counter is cleared to 0, right? હવે જે next T આવશે clock transition, ત્યાં તમારું SC ની વેલ્યુ શું થઈ ગઈ છે? 0, right? This causes the timing signal T0 to become active instead of T5, right? T4 થઈ ગયું, પછી એના પછી T5 clock cycle active થવી જોઈએ, રાઈટ. પણ અહીંયા એટ ટાઈમ D3 D4 તમારું SC 0 થઈ જાય છે. Right, your SC is clear, sequence counter is clear. So instead of activate the T5 clock cycle, તમારી કઈ clock cycle active થશે? T0. Right? અને so this is the timing cycle for instruction D3 D4 when SC is equals to 0. Right? So instead of active the T5 cycle, it will active the T0 timing cycle. Right? Now, this is the description of the timing control timing signals. Right? Now, next we'll see the control organization of computer system. Right, there are two major types of control organization. One is hardwire control and second is microprogram control. Right, now in hardwire control logic is implemented with gates, flip-flops, decoder and other digital circuits. Right, it has advantage that it can be optimized to produce a fast mode of operations. Right, it requires changing in wiring among the various components if the design has to be modified or changed. Right, now next is microprogram control. In microprogram control, the control information is stored in the control memory. Right, the control memory is programmed to initiate the required sequence of micro operations. Right, any required changes or modification can be done by updating the microprogram in the control memory. Right, so આ તમને 2 or 3 marks માં પૂછાય છે. Explain hardwire control and microprogram control, or difference between hardwire control and microprogram control. Right, so first is hardwire control logic is implemented with the gates, flip-flop, decoder and other digital circuits instead of on the other side, microprogram control, the control information is stored in the control memory. Right, and control memory is programmed to initiate the required sequence of micro operations. Right, now in if you perform your operations using the hardwire control organization, right, then if you want to modify or change your design, right, then you have to change the wiring amongst all the components. Right, જ્યારે માઇક્રો પ્રોગ્રામ કંટ્રોલથી તમે કોઈ પણ ઓપરેશન પરફોર્મ કર્યું હશે તો તમારે આખું બધું વાયરિંગ ને બધું ચેન્જ કરવાની જરૂર નથી. જસ્ટ યુ હેવ ટુ અપડેટ ધી માઇક્રો પ્રોગ્રામ ઇન ધી control memory. Right, so this is about the hardwire control and microprogram control. Now next is instruction cycle. Right, now a program residing in the memory unit of the computer consists of sequence of instructions. Right, કોઈ પણ પ્રોગ્રામ છે જે મેમરી યુનિટમાં સ્ટોર છે કમ્પ્યુટરમાં. રાઈટ, એમાં શું હશે પ્રોગ્રામમાં? નંબર ઓફ ઇન્સ્ટ્રક્શન્સ. Right, in the basic computer each instruction cycle consists of following phase. Right, તમે કોઈ પણ પ્રોગ્રામ છે, રાઈટ, એમાં શું હશે? નંબર ઓફ ઇન્સ્ટ્રક્શન્સ હશે. હવે એ જે નંબર ઓફ ઇન્સ્ટ્રક્શન તમે કોઈ પણ પ્રોગ્રામ રન કરો તો એ જ બધી ઇન્સ્ટ્રક્શન છે, રાઈટ, બેઝિક કમ્પ્યુટરમાં એ કયા ફેઝમાંથી પાસ થશે? એ એના આ ડિફરન્ટ ફેઝ છે. રાઈટ, ફર્સ્ટ શું થશે? તમારી ફર્સ્ટ ઇન્સ્ટ્રક્શન છે પ્રોગ્રામની, એ મેમરીમાંથી ફેચ થશે. સો ફેચ એન ઇન્સ્ટ્રક્શન ફ્રોમ ધી મેમરી. રાઈટ, હવે મેમરીમાંથી ઇન્સ્ટ્રક્શન તમારી ફેચ થઈ ગઈ, પછી શું થશે? એ ઇન્સ્ટ્રક્શન ડીકોડ થશે. રાઈટ, બીકોઝ મેમરીમાં બાઇનરી ફોર્મમાં સ્ટોર હશે. Right, so it will decode the instruction. Right, then next is after decoding the instruction it will read the effective address from the memory if the instruction has an indirect address. If the instruction has direct address, so directly જે પણ ઓપરેશન હશે it will perform that operation, but that if that instruction has the indirect address, so એનું એડ્રેસ તમારે મેમરીમાં સ્ટોર હશે, right? So it will read the effective address from the memory. I mean indirect address and read કરશે, then from that address it will fetch the data and perform the operation, right? So third is read the effective address from memory if the instruction has an indirect address, right? Now after completing the decoding and read the address, it will execute the instruction, right? If your instruction is direct type, then it will omit this third step and directly execute the instruction. But if your instruction has an indirect address, it will read the effective address from the memory, then execute the instruction. Right? Now, after executing the first instruction, the control goes to the first step, that is fetch an instruction from the memory for the next instruction. Right? So this cycle is for the one instruction only. રાઈટ, ફર્સ્ટ ઇન્સ્ટ્રક્શન છે એ મેમરીમાંથી ફેચ થશે, પછી ડીકોડ થશે, જો ડાયરેક્ટ એડ્રેસ હશે તો ડાયરેક્ટ એક્ઝિક્યુટ થશે, અને જો ઇનડાયરેક્ટ એડ્રેસ હશે તો ઇફેક્ટિવ એડ્રેસ મેમરીમાંથી તમારું રીડ થશે, રાઈટ. આફ્ટર એક્ઝિક્યુટિંગ ધી ફર્સ્ટ ઇન્સ્ટ્રક્શન, યોર કંટ્રોલ ટ્રાન્સફર ટુ ધી ફર્સ્ટ સ્ટેપ, right? And follow this all step for the second instruction this until your halt instruction is encountered. Right? જ્યારે તમારી halt instruction આવશે, that will stop processing this sequence. Right? So this 4 steps is followed by basic computer, right, to execute the program. Right? Now let's see the each and every phase in detail. Right? So first is fetch and decode. Right? So initially the program counter, that is PC, is loaded with the address of the first instruction in the program, right? Then the sequence counter SC is clear to 0 and providing a decoding timing signal T0, right? After each clock pulse, your sequence counter is incremented by 1, so that the timing signals go to the sequence T0, T1, T2 and so on, જે આપણે last timing diagram માં જોયું है, right? The micro operations for the fetch and decode phase are as follows, right? So first at time T0, your program counter, right, will be your program counter loaded with the address of the first instruction, right, will transfer this address into address register, right? Then instruction stored in that address register, right, on that particular memory location will transfer to the instruction register, right? So હવે તમારી instruction memory માંથી ક્યાં આવી ગઈ? Instruction register માં, right? And your program counter will be incremented, right? Then instruction register માં 12, 13 and 14 નંબરના બીટ પર જે ઓપકોડ હશે, that will decode it to D0, D1, D2 up to D7, જે આપણે ડાયાગ્રામમાં જોયું, right? And IR ની જે 0 to 11 position હશે, that will be transferred to the AR register, right? અને 15th beat પર જે beat હશે, that will transfer to the I flip flop, right? આ બધું આપણે ડાયાગ્રામમાં જોયું already. Now next is after fetch the instruction, right, from memory, next is determine the type of the this will decode the instruction, right? This is your first step. Then it will, second step is decode the instruction. So it will decode the instruction using the decoder, right? Then third step is determine the type of the instruction, because third step માં આપણે શું કરતા હતા, that we have to find out that instruction is a direct address type or indirect address type, right? So during time T3, the control unit determines the type of the instruction, right? T0 પર શું થાય છે? તમારો જે program counter છે, right, that is loaded with the address of the first instruction, right? then sequence counter is clear to 0 અને એ જે પ્રોગ્રામ કાઉન્ટરમાં જે એડ્રેસ હશે ફર્સ્ટ ઇન્સ્ટ્રક્શનનું that will be loaded to AR. That at time T1, right, એ જે તમારું એડ્રેસ છે, રાઈટ, એ મેમરીમાં ત્યાં જે instruction store છે, that instruction is loaded into IR register and program counter is incremented by 1, right. Then at time T2, right, it will perform the decoding operation of the instruction, right. At time T3, right, it determines the type of the instruction, that is it is memory reference instruction, register reference instruction, or input output instruction, right. Now if D7 bit is set to 1, then instruction must be either register reference or input output instruction, right. If D7 is equals to 0, right, if D7 is equals to 0, then it is memory reference instruction, right. So at time T3, it will determine the type of the instruction, right. Now let's see this શું કહેવાય procedure with the use of flowchart. Right. So initially your sequence counter is equals to 0, right. Then at time T0, program counter will fetch the address of the first instruction and stored into address register, right. Then at time T1, your instructions from the memory will loaded into instruction register and your program counter increment by 1, right. So first instruction તમારી મેમરીમાંથી IR રજિસ્ટરમાં આવી ગઈ, so program counter will increment it, right. Then next is performing decoding operation, right. So decode operation code in instruction register 12 to 14 bit, right. जो operation code ના 3 bit છે 12, 13, 14, એ decode થશે into D0 to D7, right. જે 0 to 11 bit છે that will be stored into address register, and then 15th bit છે that will pass to the I flip flop, right. Then next is check the D7 bit. If the D7 bit is 1, then it will be either register instruction, register reference instruction, or input output instruction, right. Now check the I bit, I flip flop value, right. If the I flip flop value is equals to 1, then it will input output instruction. If this value, then execute the input output instruction and set sequence counter to 0, right. If it is equals to 0, then it is register reference instruction, then execute the register reference instruction at time T3 and set sequence counter to 0, right. Now if D7 bit is equals to 0, then it must be memory reference instruction, right. Then check I flip flop value. If I is equals to 1, then it is indirect address instruction, right. Then store, then fetch the indirect address from the memory and store into AR register and execute the memory reference instruction and set the sequence counter to 0, right. If it is 0, then do nothing, right, because it is a direct instruction, and execute the memory reference instruction, right. So this will for the one instruction of your program, right. After executing the first instruction of the program, your sequence counter is set to 0 and it will transfer to the next program counter, right. So at next program counter, your second instruction of the program will be stored, right. So from that it will store the address into AR register and follow the same procedure until it will fetch the hold instruction. Getting all of you until this?
Yes, ma'am.
At least say yes or okay. So નેક્સ્ટ અત્યાર સુધી આપણે શું જોયું કે કેવી રીતે તમારી ઇન્સ્ટ્રક્શન બેઝિક કમ્પ્યુટરમાં ફેચ થાય છે, પછી કેવી રીતે ડીકોડ થાય છે, અને આફ્ટર ડીકોડિંગ એની ટાઈપ કહી છે એના પરથી next at time t3 it will execute the instruction, right? So let's see the uh, types of instructions in detail, how different types of instruction can be controlled by the basic computer, right? So here D7I T3, right, it is common to all register instruction will be denoted by R, right? Whenever your D7 is equals to 1, right, and I is equals to 0 at time T3, right, you can say that that this instruction is of register reference instruction, right? ક્યારે તમારી instruction register reference instruction હશે જ્યારે D7 બીટ જે છે, right, જ્યારે D7 બીટ જે છે એ 1 છે, right? આપણે ફ્લો ચાર્ટમાં જોયું whenever D7 bit is 1, right, and flip-flop value is 0 at time t3, then it is register reference instruction, right? So એને symbolically represent કર્યું છે D7I T3, right? અને આપણે એને commonly represent કરશું with small r, right? And instruction register I is equals to BI, right, which specify the bit in the instruction register, right? So first register reference instruction is CLA, right? So R that denote the register reference instruction, right? And B11 is the bits in IR register for 0 to 11, right? RB11 is for CLA instruction. CLA instruction is used to clear the accumulator, right? So whenever you want to clear the accumulator, use the CLA register reference instruction, right? Same for next instruction is CLA. Already you know all the instruction name, right? So હું થોડું ફાસ્ટ જાઉં છું because આ તમારું almost studyingના 2 or 3 chaptersમાં repeat થાય છે, right? So CLE, that is clear the E register, right? Then CMA, that is complement the accumulator, right? Then CME, that is complement the E register. CIR, that is circulate right, right? Then CIL, circulate left, right? Then INC, that is increment accumulator by 1, right? Then SPA, right, skip if positive, right? Skip if accumulator is positive, then skip the next instruction and program counter is incremented by 1, right? SNA, that is skip if negative. If accumulator value is negative, right, then skip the next instruction and program counter incremented by 1, right? Then SZA, then skip if accumulator is 0, right, and program counter plus plus. Then SZD, that is skip if E register value is 0, right, then program counter plus plus. Then next is halt instruction, right? Start halt instruction clears the start stop flip flop, right, and stop the sequence counter from counting and restore the operation of the computer, right? So this is your halt instruction. Now next is memory reference instruction, right? So in order to specify the micro operations needed for execution of each instruction, right, it is necessary that function that they are intended to perform be defined precisely, right? So to perform the some basic operations, right, we have memory reference instructions, right? Now we have total 7 memory reference instructions. The decoded output DI for I is equals to 0 to 6 from the operation decoder that belongs to each instruction is uh, included for to to represent the memory reference instructions, right? Now the effective address of the instructions is in the address register AR, sorry. And whenever at time t2, right, I is equals to 0, or during time t3 when I is equals to 1, the execution of the memory reference instructions start with the timing signal t4, right? So whenever we can say that our instruction is a memory reference instruction, when our, see in the, huh, when our value of d7 is 0, right, then we can say there this instruction is of memory reference instruction, right? In memory reference instruction we have two address type, direct address or indirect address, right? So first memory reference instruction is AND instruction, AND to accumulator, right? So this instruction that performs the AND logic operation on pairs of bits in accumulator and the word and the memory word, right, specified by the effective address. The result of AND between AC and memory word will be stored into accumulator only, right? Now the micro operation which used to perform the AND operations are like this. First, address of the memory will be stored into data register at D0 T4, right? Now at the next clock pulse, AND operation between data register and accumulator will be performed, and result of this AND operation will be stored into accumulator only, right? And sequence counter set to 0, right? Now why we use the D0 here, right? Because decoder operation D0 is activated when it will find the instruction and in the active state, right? Because binary value for AND operation is 000, right? Binary value for AND operation is 000, right? So decoder માં કયું signal activate થશે? D0, right? At time T4, right? Because T0, T1, T2, T3 સુધી તો એ fetch કરશે, પછી decode કરશે, right? And at time T3 it will find that it is a memory reference instruction, right? So time T4 પર એ memory reference instruction છે, એના next clock pulse માં at time T4 it will perform the AND operation, right? અને AND કોની વચ્ચે થશે? ડેટા રજિસ્ટરમાં જે મેમરીમાંથી વેલ્યુ સ્ટોર થઈ છે એ અને એક્યુમ્યુલેટર વચ્ચે, અને એનું result ક્યાં સ્ટોર થશે? In accumulator only, right? Now after performing the AND logic operation between DR and AC, right, same clock transition clears the SC value to 0, right, and transfer the control to the timing signal to T0 to start the new instruction cycle, right? So after performing the AND operation at timing clock signal T5, right, SC ની value 0 થશે. So next instruction cycle હવે પાછી start થશે ક્યાંથી? T0 થી. Getting? Now next is add operation. Right, this instruction adds the content of the memory word specified by the effective address to the value of the accumulator, right? And the sum, the answer will be transferred to the accumulator only with the carry output C out, right? And that carry output is transferred to the E flip-flop, that is extended accumulator, right? Now see this operation using micro operation DRMAR, right? Memory, from this memory address, right, the data will be transferred to the DR register, right, at D1 T4. where D1 is used to specify the add operation, because for add operation binary equivalent is 001, right? So 001 નું ડેસિમલ શું થશે 1. સો D1 એટ ટાઈમ T4. હવે T4 કેમ છે? T0, T1, T2, T3 સુધી તો આપણે ઇન્સ્ટ્રક્શન જોયું કે T0 પર ઇન્સ્ટ્રક્શન ફેચ થશે, રાઈટ? પછી T1 પર શું થશે? T1 પર ડિકોડ થશે, રાઈટ? પછી T2 પર શું થશે? રાઈટ, કે એક એને શું કહેવાય, સોરી, T0 પર શું થશે? પ્રોગ્રામ કાઉન્ટરમાંથી એડ્રેસ રજિસ્ટરમાં આવશે. પછી T1 પર શું થશે? મેમરીમાંથી ઇન્ક્રીમેન્ટ સોરી ઇન્સ્ટ્રક્શન રજિસ્ટરમાં આવશે. T2માં એ ડીકોડ થશે, રાઈટ? T3માં એ જે તમારી ઇન્સ્ટ્રક્શન ટાઈપ છે એ ડિફાઇન થશે, રાઈટ? અને T4 પર એ એક્ઝિક્યુટ થશે, રાઈટ? સો T4 પર તમારી એડ ઇન્સ્ટ્રક્શન એક્ઝિક્યુટ થશે, રાઈટ? નાઉ એમાં શું થશે? મેમરીમાંથી ડીઆર રજિસ્ટરમાં તમારી વેલ્યુ આવી ગઈ, પછી એડ થશે ડીઆર પ્લસ એસી એન્ડ output will be stored into accumulator only, right? And if some carry is generated, that is C out, that will stored into extended accumulator E, right? And sequence counter is set to 0, right? The same two timing signal T4 and T5 are used again, but with operation decoder D1, right? T4 પર DR માં સ્ટોર થશે અને T5 પર એડ ઓપરેશન પરફોર્મ થશે, રાઈટ? બટ ડિકોડર કયું યુઝ કર્યું છે આપણે? D1, because D1 is a decoder for add operation, right? So after the instruction is fetched from the memory and decoded, only one output of the operation decoder will be active, and that output determines the sequence of micro operation that the controller follows during the execution of the memory reference instruction, right? Now next memory reference instruction is LDA, right? That is load to accumulator. This instruction transfer the memory word specified by the effective address to accumulator, right? So D2 T4, right? So at timing clock pulse T4, right, which decoder is activated to perform the LD instruction? D2, right? Because binary code for LD instruction is 010, which is equivalent to decimal number 2. So which decoder is active? D2, right? D2 T4. So first, from the memory, your data will be stored into DR register, and that DR register data will be transferred to the accumulator. So this will load the memory word into effective address of the accumulator, right? Now, as there is no direct path from common bus to accumulator, right? So we have to use the adder and logic circuit, right, which use the DR register, right, to transfer the data from memory to accumulator, right? So that's why first it is necessary to read the memory word into data register, right? Then transfer the content of the data register into accumulator. Directly આપણે મેમરીમાંથી accumulatorમાં ટ્રાન્સફર નહીં કરી શકીએ, right? Because there is no direct path between memory and accumulator, right? So we have to first આપણે જે common bus system જે બધા રજિસ્ટરની જોઈ લઈએ, યાદ છે લાસ્ટ ટુ લાસ્ટ લેક્ચરમાં કે જેમાં બધા રજિસ્ટર હતા અને common bus system હતી, રાઈટ? એ common bus systemમાં મેમરીથી accumulator વચ્ચે કોઈ direct path નથી, જો તમે જોશો તો, રાઈટ? સો આપણે શું કરવું પડે? મેમરીમાંથી પહેલા ડેટા રજિસ્ટરમાં તમારા ડેટા સ્ટોર કરવા પડે, પછી એ ડેટા રજિસ્ટરમાંથી એક્યુમ્યુલેટરમાં ટ્રાન્સફર કરવું પડે. સો દેટ્સ વાય વી હેવ ટુ પરફોર્મ ધીસ ટુ માઇક્રો ઓપરેશન્સ, રાઈટ? સો આફ્ટર transferring the data from DR to accumulator, right, your sequence counter is set to 0, right? Now next is STA, that is store accumulator, right? This instruction store the content of the accumulator into memory, right? LDA શું કરે છે? મેમરીમાંથી એક્યુમ્યુલેટરમાં તમારે ડેટા સ્ટોર કરવા હોય એટ ધ ટાઈમ યુઝ ધી LDA ઇન્સ્ટ્રક્શન. હવે એક્યુમ્યુલેટરમાંથી મેમરીમાં તમારે કોઈ ડેટા સ્ટોર કરવા છે, then use which instruction? STA memory reference instructions. Right? Now the output of the accumulator is applied to the bus and the data input of the memory is connected to the bus. So we can execute these micro operations directly. Right? Because accumulator નું જે output છે that is applied to the common bus. Right? And the data input of the memory is connected to the common bus. So we can perform this operation directly. So directly accumulator data તમારા ક્યાં આવી જશે? Memory register માં. Right? And sequence counter is set to 0. Right? Next instruction is burn, that is branch unconditionally. Right? This instruction will transfer the program to the instruction specified by the effective address. Right? Now program counter holds the address of the instruction to be read from the memory in the next instruction cycle. Right? So program counter is incremented at time t1 to prepare it for the address of the next instruction in the program sequence. Right? So burn instruction શું કરશે? Burn instruction allow the programmer to specify the instruction out of sequence and આપણે તમે લોકો સીમાં કરતા હતા, રાઈટ? જમ્પ ઇન્સ્ટ્રક્શન જે તમે યુઝ કરતા હતા, right? The same way in basic computer you can use the burn instruction, right? Burn instructions શું કરશે? Burn instructions allow the programmer to specify the instruction out of the sequence. સિક્વન્સમાં જ પરફોર્મ થાય છે નોર્મલી, બરાબર? પણ મારે સિક્વન્સમાં પરફોર્મ નથી કરવું. I want to transfer the control of my program into some non-sequential instruction. Right? So we can say that the program branches unconditionally using the burn instruction. Right? Now to execute this instruction, we have this micro operation. Right? Address register value will now transfer to program counter. Right? And sequence counter is set to 0. આનો મતલબ શું થાય? The effective address of the address register from the address register is transferred to the common bus system to PC. That common bus system માં શું થશે? In common bus system માં જે address register છે એની value હવે ક્યાં transfer થશે? PC માં. Right? And resetting sequence counter to 0 transfer the control to T0. Right? So the next instruction is then fetched and executed from the memory address given by the new value in PC. Right? So PC ની જે next value હશે એની જગ્યાએ આપણે change કરીને કઈ value આપી? જે memory address ની જે value છે. So this is your burn or branch unconditional. Right? Next instruction is BSA, that is branch and save return address. Right? So this instruction is useful for branching to a portion of a program called subroutine or procedure. Right? C માં જે આપણે function use કરતા, યાદ છે? So function માં શું થતું? જ્યારે function call થતું, right? તો next address કયું ટ્રાન્સફર થાય? તમારી જે function ની definition જે address પર store હોય એ. રાઈટ? એવું નથી થતું ને કે તમારું એક ફંક્શન કોલ જે છે એના પછીની ઇન્સ્ટ્રક્શન તમારી પ્રોગ્રામની રન થાય, પણ ફંક્શન કોલ થાય ત્યારે તમારું ટ્રાન્સફર ક્યાં થઈ જાય? ફંક્શન ડેફિનેશન જે એડ્રેસ પર સ્ટોર છે. Right? So same way, whenever your program uses subroutine or procedure, subroutine is same as your function. Right? So whenever your program use subroutine or procedure, right, at that time which instruction is used to transfer the control? BSA. Right? So BSA instruction stores the address of the next instruction in sequence into a memory location specified by the effective address. The effective address plus 1 is then transferred to the program counter to serve the address of the first instruction in the subroutine. Right? So એના માઇક્રો ઓપરેશન્સ કયા છે? Right? So program counter ની જે વેલ્યુ છે એ હવે મેમરી એડ્રેસમાં જતી રહેશે તમારી. Right? And memory address will incremented by 1. right? And that memory address is now stored to the program counter and sequence counter is set to 0, right? હવે આપણે એક ડાયાગ્રામથી સમજીએ BSA instruction, right? Consider, sorry, consider that uh, your instruction at the memory location 20, right? Consider the BSA instruction is at the memory location 20, right? હવે 21 પર કઈ હશે next instruction હશે, right? Now your AR is equals to, suppose that your address register suppose hold the effective address 135, right? અને 136 પરથી તમારું subroutine start થાય છે, right? Now BUN is branch unconditionally 135, right? So હવે આ શું છે? Memory, program counter and AR at the time T4. હવે at the time T5 શું થશે? Right? So after execution of memory and program counter, your memory will be like this, right? 20 memory location પર શું છે? BSA instruction છે, right? 21 પર તમારી next instruction છે, right? So હવે જે next instruction છે, જે 21 પર સ્ટોર છે, એ ક્યાં આવી જશે? 135 પર, right? Because અહીંયા તમે ક્યાં after subroutine execution, right? તમે ક્યાં જમ્પ કરવાનું લખ્યું છે? 135 પર. So આ 21 પર જે instruction છે એ actually હવે ક્યાં રન થશે? 135 પર, right? અને 136 પર, right? તમારું subroutine execute થશે. So this is your BSA instruction, right? BSA 135. This is your subroutine call. અને 135 જે છે, અહીંયા BSA ની બાજુમાં જે 135 લખ્યું છે એ કયું એડ્રેસ છે? તમારું રિટર્ન એડ્રેસ. સો આફ્ટર એક્ઝિક્યુટિંગ ધી સબરૂટીન તમારે રિટર્ન ક્યાં થવાનું છે? 135 મેમરી લોકેશન પર, રાઈટ? આ જે તમારું કોલ થયું છે BSA ઇન્સ્ટ્રક્શન, સો એ સબરૂટીન એક્ઝિક્યુટ કરશે, right? After executing the subroutine, return કયા એડ્રેસ પર થવાનું છે? That will be specified here, 135, right? If it is 121 here, right? So તમારું after executing the subroutine, your transfer, your program counter value will be 121. આ શું છે? તમારું સ્પેસિફાઈ કરે છે return address 135, right? So after executing this subroutine, it will execute the next instruction at which memory location? Sorry, 135, right? So this is your BSA instruction. Next is ISZ instruction, right? That is increment and skip if 0. Now this instruction increment the word specified by the effective address, and if the incremented value is equals to 0, the program counter is incremented by 1. Now, normally the programmer stores the negative numbers whenever it is used in 2's complement in the memory word. As the number is negative, is repeatedly incremented by 1 and it eventually reaches to value to 0. At that time, program counter is incremented by 1 in order to skip the next instruction in the program. Right? Now it is not possible to increment a word inside a memory, right? It is necessary to read a word from the data register and increment data register and store the word back to the memory, right? So these are the micro operation to perform the ISZ instruction, right? Because there is it is impossible to increment the memory word, right? So memory માંથી આપણે જે પણ instruction હશે એને ક્યાં store કરી દેશું? DR register માં, right? Then increment the DR register, right? And again store the value of DR into memory, right? Now if DR is equals to 0, then program execute. If DR is not equals to 0, then store into memory register, right? So increment and skip if 0, right? So program counter plus plus થશે અને જો 0 હશે then skip, right? And synchronous counter is set to 0. right? So this is about the different memory reference instructions, right? Now next is, oh, already it's 10:50. Okay, so next time we will see the input output of the basic computer, right? અત્યાર સુધી આપણે શું જોયું? રજિસ્ટર રેફરન્સ ઇન્સ્ટ્રક્શન્સ જોઈ, મેમરી રેફરન્સ ઇન્સ્ટ્રક્શન્સ જોઈ. હવે નેક્સ્ટ ટાઈમ આપણે જોશું ઇનપુટ આઉટપુટ ઇન્સ્ટ્રક્શન્સ, રાઈટ? બિકોઝ અત્યાર સુધી જે આપણે જોઈએ એ બધું કમ્પ્યુટરની અંદર જોયું, રાઈટ? કે કમ્પ્યુટરની અંદર કેવી રીતે થાય છે. બટ અ કમ્પ્યુટર કેન સર્વ no useful purpose unless it communicate with the external environment, right? કમ્પ્યુટર ની અંદર બધું થઈ ગયું, પણ એ કશે ઇનપુટ નહીં આપતું હોય કે કશેથી કશે આઉટપુટ નહીં જનરેટ કરતું હોય, રાઈટ? સો એનો કોઈ મતલબ નથી, રાઈટ? સો જે પણ ઇન્સ્ટ્રક્શન અને ડેટા જે મેમરીમાં સ્ટોર છે, રાઈટ, તો એ કશે ઇનપુટ ડિવાઇસથી આવવા જોઈએ, કોઈ આઉટપુટ ડિવાઇસમાં ટ્રાન્સફર થવા જોઈએ, રાઈટ? એ બધું ઇટ ઇઝ વેરી નેસેસરી, બિકોઝ જો એવું ઇનપુટ આઉટપુટ ટ્રાન્સમિશન નહીં થાય દેન એ જે કમ્પ્યુટરમાં જે ડેટા છે એનો કોઈ મિનિંગ નથી રહેતો, રાઈટ? સો એ કેવી રીતે ઇનપુટ આઉટપુટ ડિવાઇસમાંથી કેવી રીતે કમ્યુનિકેશન થાય છે અને કઈ કઈ ઇન્સ્ટ્રક્શન યુઝ થાય છે ટુ પરફોર્મ ધ ઇનપુટ આઉટપુટ ઓપરેશન, ધેટ વી વિલ સી ઇન નેક્સ્ટ લેક્ચર. ઓકે, અત્યાર સુધી બધાને સમજ પડી? અત્યાર સુધી જે કવર કર્યું એ રજિસ્ટર રેફરન્સ ઇન્સ્ટ્રક્શન, મેમરી રેફરન્સ ઇન્સ્ટ્રક્શન, પછી જે પેલો ફ્લો ચાર્ટ કર્યો ઇન્સ્ટ્રક્શન સાયકલનો, રાઈટ? દેન કંટ્રોલ યુનિટ જોયું બેઝિક કમ્પ્યુટરનું, જેમાં 2 ડીકોડર હતા અને સિક્વન્સ કાઉન્ટર હતું. દેન કંટ્રોલ લોજિક ગેટ્સ હતા, રાઈટ? દેન હાર્ડ વાયર કંટ્રોલ એન્ડ માઇક્રો પ્રોગ્રામ કંટ્રોલનો જે ડિફરન્સ જોયો, રાઈટ? આજે જે કરાવવામાં કશામાં કઈ પ્રોબ્લેમ છે?
No, ma'am.
ઓકે, સો વન મોર થિંગ, જે આ ચેપ્ટર ચાલે છે અને પછીના પણ એ પણ ચેપ્ટર્સ ચાલશે બધા, રાઈટ? જે સર તમને અસેમ્બલી પ્રોગ્રામ કરાવે છે એના માટે જે આપણે એક ડાયાગ્રામ કરેલો, ખબર? જેમાં બેઝિક કમ્પ્યુટરના બધા રજિસ્ટર હતા અને કોમન બસ સિસ્ટમ હતી, કોમન બસ સિસ્ટમ ફોર બેઝિક કમ્પ્યુટર, રાઈટ? એમાં 3 ઇનપુટ સિગ્નલ હતા, S0, S1, S2 કોમન બસ હતી, પછી બધા રજિસ્ટર હતા, રાઈટ? સો એ જે ડાયાગ્રામ છે એ તમને પરફેક્ટલી મગજમાં હોવો જોઈએ, તો તમને ખબર પડે કે ડેટા રજિસ્ટરનો કેમ યુઝ કર્યો છે, પ્રોગ્રામ કાઉન્ટરનો કેમ યુઝ કર્યો છે, રાઈટ? આજે પણ જેટલી પણ ઇન્સ્ટ્રક્શન જોઈ એમાં જે માઇક્રો ઓપરેશન જોયા, તો કેમ એક્યુમ્યુલેટરમાંથી આપણે ડાયરેક્ટ ડેટા ટ્રાન્સફર નથી કરતા મેમરીમાં, રાઈટ? બિકોઝ એની વચ્ચે કોઈ કોમન કનેક્શન નથી, રાઈટ? સો આપણે એક્યુમ્યુલેટરમાંથી ડેટા રજિસ્ટરમાં ટ્રાન્સફર કરવું પડે અને પછી ડેટા રજિસ્ટરમાંથી કોમન બસમાં ટ્રાન્સફર, મેમરીમાં ટ્રાન્સફર કરવું પડે, રાઈટ? સો એના માટે તમને એ ડાયાગ્રામ પ્રોપરલી મગજમાં ખબર હોવી જોઈએ, રાઈટ? સો બધા એ ડાયાગ્રામ થોડો પ્રોપરલી જોઈ લેજો. ઓકે, નાઉ આઈ વિલ શેર ધી અટેન્ડન્સ લિંક.